Right, good morning everyone. Thank you for making it out here early morning to see the presentation we have for you today. It's about BIM for low-rise. So we're going to walk you through our journey implementing BIM in the low-rise industry, specifically working with Mattamy Homes, one of the largest builders in the country. So we're going to show you how this whole thing started, where we are now, and all the stuff that we went through so far. So the topics that we're going to be covering today is, first of all, why BIM for low-rise, the complexity of the low-rise projects, the implementation itself, the processes and outputs that we've developed, the lessons that we learned from this whole implementation, and then finally we'll have time for any questions that you might have for us. Also, my name is Jad and this is Joris, and we're from BIMstudio. So first off, why BIM, specifically why for low-rise? So the first thing is to shorten the time to market. So if somebody's buying a house or buying a place to live, they don't want to wait 2 to 3 years to be able to move into it. Obviously, with the housing problem that we're having, this time should be shortened maybe to 6 months. So if somebody buying a house or the property goes in the market until somebody's able to move into it, it should be a lot shorter than it is now. The second thing that we're trying to do is increase the actual quality of production of the house. For a lot of people, buying a home is the biggest investment they do in their entire lives. Therefore, that investment should be sound and solid. And then also, from the building standpoint, decreasing the change orders, design changes, which lead to inefficiencies and poor quality of construction. And then finally, the value for money. So are we getting the best product that we can for what we're paying for? Can we get a better product for the same price? Or can we even get a better product for a lower price where even everybody actually comes out on the top? So it really boils down to increasing quality for the end user who's going to be occupying that residential home. So all of you know BIM, but for us, for this particular project, obviously BIM stands for Building Information Modeling, but we look at it more like management. And we use it for the entire process from design to handoff. And throughout that process, we extract a lot of useful information that help us optimize and provide a better product. Keeping in mind that we try to create a sort of a global or a platform, not a global, but more accessible for everyone, so you can access it from every device that you have. And that includes the people on site who are actually building the product. So if you look at a typical or current process, we basically start with an input, which will include a lot of disciplines, a lot of drawings, a lot of information coming from design, from HVAC, from energy modelers, from suppliers, the land itself, where the project is positioned, what trades we have on hand to execute this job. And on the other hand, we have the output, which obviously is procurement, the sales drawings, the pyramid drawings, the estimation, the tender packages, the construction itself. Now currently, each project and each input segments are unique to projects. So when you start a project, it's different from the one you started before, and then the trades or anybody else that you might be working with are also different. So the way we actually connect these two right now, it's a little messy. So we don't really know who's responsible for which output. And then the builder is left to try to manage this entire thing, which becomes quite difficult. So there is no standardization, there's no continuum in this entire process. Every time starting a new project, you have to figure out this new relationships again and again and again. So what we introduced is the concept of a BIM hub. So the BIM hub's primary job is to basically do this, is to take all the inputs into the BIM hub, which then can standardize the output to the project, which makes the builder's life easier because they can now compare project to project, and everything is more standardized. Also, this allows you to work with any number of consultants to generate the input, because the input can come in any shape or form, and the BIM's hub's job is to actually control and standardize and categorize these inputs into specific modulars that generate consistent and standardized output for the project. Because of these attributes for the BIM hub, so the BIM hub is also able to do this, but from BIM models instead of drawings, Excel sheets, and anything like that. And then it will spit out the output in a format that the builder or the stakeholders of the project are able to digest, communicate about and talk about and also manage. So because of these attributes, what we saw with the concept of the BIM Hub was able to grow from first starting with design models, going to structural, HVAC, framing, and slowly started a ripple effect, which started swallowing all the other disciplines, processes, outputs that the builder needs. On top of that, something interesting really started to happen, that the BIM Hub now is able to give you extra outputs that you were not able to get before from the traditional process, which now you can design your kitchens and stairs ahead of time, you can design your kitchens ahead of time, you can start going into prefabrication and offsite construction, you can start providing as-built information to the clients who are purchasing those homes. You're able to generate lot-specific information to give to anybody on the site that's building a specific lot. So obviously the BIM Hub was inspired by four key concepts. One was the standardization of components. So trying to look at the actual measurements of the materials that we buy for construction and try to design accordingly. So for example, if you buy a 4x8 sheet of OSB, try not design measurements that are 3 feet and maybe 8 inches. Then you strip the 4 inches of the sheet and then that becomes waste. Try to respect the materials that you're working with. And all these things are possible because of the parametric design nature of BIM. The other thing was the automation and breaking down the process into small manageable pieces, taking clues from the automotive industry, which has developed tremendously over the past 50 years, whereas the framing industry or the home building industry hasn't. So we always joke that if you bring a framer that's been in coma for 50 years and you put them on site today, they will still be able to perform better than the framers who are on site today because they're actually more skilled just with the nail and hammer. So that was pretty bad for our industry. The other thing is this process is data driven, so we're able to farm data from previous projects and collect data on the projects we're working on to help us do better, make better decisions in the future. Finally, the tailored information, that's an inspiration from, for example, IKEA. So we're rethinking or repurposing the construction documents on site to make them trade specific. So we give foundation cut sheets to the concrete guys, we give framing elevations and framing drawings to the framing crews, cladding drawings for the cladding crews and so on. So you're not looking at a sporadic sort of construction dock with everything else overlaid and you're not able to figure out what you're doing. And we'll show more of this in a bit. But it's important to note the complexity of the low-rise project. It's, in my opinion, it could be as complex or even more complex than a high-rise or institutional building for the reasons you'll see now. So if you take a look at a sort of a run-of-the-mill community, you can see it's going to have a lot of house styles, they have a lot of design options, a lot of specific lots. It takes a lot of coordination, and then there's a lot of design changes that happen as you're building all those individual houses. So you may end up with over 1,000 3D models that you need to manage. So if we drill down even a little deeper and we take a look at this community here, it comes with different housing typologies. So you can have single family homes from 30-foot lots to 50-foot lots. You can even have townhouses, back-to-backs, low-rise. You can even have high-rise in these communities, not to mention the commercial and institutional buildings like in schools, malls, community centers, etc. So it's a quite complex project that needs a lot of planning that go into it. But for today, let's look into the single family home, the simple 30-foot lot. And even this one comes with different styles that the clients can buy, different elevation styles, different materials, different requirements for how they're going to be built, how they're going to be insulated, and so on and so on. A lot of details that go into that. So you can have up to 4 different styles in each one of those homes. And if that complexity wasn't enough, you can actually go a step further and imagine that each one of those house models to us, it doesn't mean only the design model, it actually comes with its own structural framing, HVAC, and plumbing model to enable this high-level coordination. And then we go into the design options. So if the client decides to purchase the ensuite upgrade, this has repercussions on the structural framing, HVAC, and plumbing as well. And then if they decide to upgrade to the chef's kitchen, also has the same repercussions. and then so on and so on. So there's 10 different variations of upgrades that anybody can go with the house. So you have a community of 800 to 1,000 lots with different housing typology. Each typology can come with different design styles, and each design style will have different design upgrades. And that accounts to a lot of different BIM models that need to be managed. So if we take a look at the typical project, it basically starts with planning and ending construction, and you have typical stages in between. The low-rise project is no different, except for one key issue or moment in time, which is sales. So the problem that we have, that anything we do before sales is all speculation. We design all those different design options, elevation style, color packages, and so on and so on, but we don't really know what the end product is going to look like until the client comes in and purchases and chooses all those options. So our process has to be extremely agile to allow for basically kind of putting together all the design options that we did in phase one, kind of like Lego pieces, and then put the house specifically on the lot that it was purchased for. So we broke the process into two sort of main segments: the sales. During that process, we design all the product types, styles, design options, material options. When we move the product to a lot specific, then we look at lot specific issues, which is grading, sunken conditions, walkouts, structural upgrades, and exterior upgrades. So basically, you're not only designing an entire project based on speculation, but then you're redesigning it based on lot specific. Therefore, your BIM process has to be quite agile and account for these complications. So if we talk about the implementation, so how did we start trying to understand this complex project? So the first thing, we went through a phase of discovery. Obviously, this industry is super outdated. There's a lot of 2D and analog things in there, so you have to kind of go through drawings, physically printed, sometimes hand drawings, sometimes spreadsheets, and just printed schedules of stuff to be able to put all this together. So the first thing we did, we took some of the 2D drawings and converted them into our first 3D model, design model. Then we took that design model and created the structural, framing, HVAC, and plumbing models from that. Then we were able to set up our collaboration platform so we can do the clash detection, coordination, and also share with the builder how this process works. Then we did some test outputs. We focused first on the coordination and quantity takeoff or estimation. That was the priority for the implementation. And then we did some test runs in order to create drawings and other outputs using the BIM process, which basically led us to the BIM Hub concept, when we were able to generate everything we need from the single source of information, which was the BIM or Revit model. So if we take a look at what's happening right now in this process. So you start with a set of drawings, which is 2D, and it's outputted from whatever platform that you have, whether it's CAD, whether it's hand sketched, it doesn't really matter. It's a 2D drawing with 2D information on top of it. Now, ideally, this drawing will be sent off to all these different departments to generate all those different outputs, from permits, coordination, sales and marketing drawings, construction drawing, estimation. You have 2D and 2D HVAC layouts and 2D floor layouts. But in reality, that's really not what happens. What happens is something more like this. This drawing gets copied around and distributed to all those departments because they all work in silos. They don't really speak to each other. So then when the drawing is, for example, given to sales and marketing, they're going to come back with some reviews and revisions because they think, these bedrooms are too small, or this is not going to sell, and we need to move these walls, or we need to do something. The HVAC and floor layouts are going to come back with their own problems, saying our joist layouts don't work this way, or I can't run my HVAC, I'm going to have bulkheads, etc. So they each start revising their drawings based on their own needs, without taking account all the other departments. The best we've seen is that maybe the HVAC and floors can talk to each other, but sales or marketing will never be engaged in that conversation. Adding to the problem is that these processes don't actually happen at the same time. So when you go into sales and then when you go to construction, it could be a year gap. During that year, a lot would happen. For example, let's say you sourced a certain type of brick. A year from now, that brick is not available. There is a shortage. let's say you design your floor with a typical joist. A year from now, that joist is not available. Windows, you spec some sizes. A year from now, you made a deal with a better window manufacturer that has different sizes, maybe an inch off, which throws off your framing and anything like that. Maybe you sold the houses today, but then maybe 20% of them weren't sold. So now, a year from now, you give more incentive to people to buy those 20% remaining, and maybe you include some of the upgrades as standard. So now you have to rework these into the equation. So things become super complex. Now, there has been attempts into digitizing this process by creating Revit models to create this process. But what happened was basically the same, because the Revit model and BIM model was used to create a better 2D drawing or a faster 2D drawing. But all the knowledge and intelligence in that model stayed with the model, and it was only used for the purpose of drawings. Therefore, the entire process didn't really change. It became maybe a little better. At the very least, you have your second floor and first floor aligned, and maybe you have slightly more accurate elevations and sections. But that doesn't mean that you are now in the BIM process. In the BIM process, really what you need to do, you need to create these outputs directly from the BIM model, keeping in mind that this BIM model is actually an aggregate of all the different disciplines that go into it. Now, once you transition to this method, now you're able to create extra outputs like framing drawings, lot specifics. You can do rendering and visualization. You can do value engineering, energy modeling. Now you're able to do 3D coordination as well as site planning. These are all added extra benefits when you transition to the BIM process, which looks actually more like this. It's a continuous cycle or coordination and development and improvement on the product, and the outputs are just a byproduct of the BIM process. They're not the end goal, so you're not putting time and effort into creating them. They're almost being automatically generated by this process. So this is really done by, so we created this simple relationship matrix, if you want to call it, conceptually to figure out how we're going to do this process very efficiently. So we decided the first step would be the BIM models, which hold the geometry, data, codes, parameters, any information that is relevant to the project. The second one would be the BIM template, which controls the graphics, the filters, the schedules, the outputs. So basically, once you link your BIM model into the template then will reorganize that BIM model based on whatever output you're looking to get. And then if there's any feedback or information or changes from the output, they get updated back in the BIM model, and then the cycle can start again. But then at this point, you're only outputting the output from the BIM model. You're not actually recreating the drawings over and over and over again. And then all the outputs are coming from the same source, which means that the drawings that go to sales, the drawings that go to construction, the drawings that go for procurement and tendering are basically the same set of drawings or the same set of information. And if there's any feedback from any of these departments, they will come back to the source and it will be updated. So with this newfound knowledge and process in place, we moved on to a pilot project, which was quite a big one. We took on a community that has 4 different styles from 30, 34, 36, and 43 foot lots. There's 20 houses altogether, I believe. And then in terms of lots, after sales and everything, specific lots, I think there's about 500. So from this process, we developed our own benchmark model in BIM. Basically the way we should model to create all these outputs. Because again, not any BIM model is able to go through the process and create these outputs carefully. The BIM model has to be considered, has to consider all these outputs and all the needs of the outputs, and everything has to be preset in the model and pre-coded. Otherwise, you won't get the information out. So if you don't put information in, you can't get the proper information out. And then the second, we developed some of the BIM templates and the BIM outputs that we need. And then very importantly, we created a BIM roadmap. So we basically mapped the current process, and then we put on top of it or overlaid our BIM process what we need. And just a quick note here, when you start implementing BIM or adding BIM to your process, you need to understand that some of the traditional tasks will have to shift around. For example, you need to put in more information ahead of time. So we had to engage floor designers, HVAC designers ahead of time to give us some schematic layouts. We had to engage window manufacturers to try to get the window sizing accurately, stair manufacturers, and things like that. And we also started to optimize all the design options and design them in a way that they're swappable. So if I'm buying an ensuite upgrade, it will fit in the location of the regular washroom and maybe walk-in closet, and not having to redesign the entire floor plan. And then finally, because we can't do the implementation on our own, so we weren't just an outside party, we were mostly integrated into the Mattamy team. So we obviously had to bring them up to speed on BIM and how to use the tools, how to use the cloud collaboration, some of the Navisworks processes, and so on. And then from then, we basically developed our project flow. And this is a simplified version of it. But basically the idea that we start with the design, and because we have the BIM hub, we don't really care how the design comes to us, whether it's 2D, whether it could be 3D, it could be a sketch on a napkin, that doesn't matter. As long as that design follows the design and BIM standards that we set up, the BIM execution plan and the project plan. Then we take that design into our 3D or BIM process. Then when the model is created, we do the value engineering, which we'll discuss a little bit later. It's basically trying to, early stages of design, trying to determine whether this product is feasible or not, trying to take a high level quantities on the exterior finishes and the high ticket items to see if that makes sense for construction, if there's enough room for profit in that project or not. Then after the value engineering is satisfactory, then we move on to creating the other BIM models and then the 3D coordination. Again, we go back and forth until the coordination is complete, which leads us to the final BIM model. When the final BIM model is there, that's when we generate our outputs. And if you notice here, the outputs are actually done at a very late stage in the process versus traditionally they start them early on. The reason they do that because they take so much time to generate the outputs. For us, the outputs are generated almost automatically, almost 90% automatically from the BIM process. So we can wait almost till the last minute to create them after our models are completely coordinated and value engineered. So then the sales process happens and the design options are selected by clients and we move on to the lot specific packages and then after that to the site. The biggest important point here is the one at the bottom, the lesson learned. So from each stage we take all the problems that we ran into and we feed them back into the BIM standards, whether that's updating the families, updating the process, adding more information, reworking the information, reorganizing it. So now our BIM templates become even more powerful. So next time around, our project's better and better and better. So it's kind of like evolves and learns from itself. So now we're going to talk about the BIM model itself and how it's developed and constructed. Joris?
Yep. Okay. Yeah, so the biggest or the most important thing in this whole process is obviously the BIM model. And we want to show you a little bit on how we build them and what choices we made to get those models to that stage where you can extract that tailored information. To begin with, what do we do with our actual models? Those models, they're separated. So one of the things that we did in the very early stage, we separated the structure from the external cladding. So we modeled twice the amount of walls in that same 3D model, but then we're able to work with the designed wood frame walls and the actual wood frame walls created by our structural or with our lumber supplier, and we can swap them. So that helps us to do that stuff. If you look at the project setup, the levels that we saw on all the projects that we grabbed, all the levels were a standard height, but it was a height that was easy to read, but was not the same height as the lumber that we bought on site. So therefore, everything that the guys did on site compared to what was in the 3D model or what was in the drawings was different. So we changed that. Then, if you look at the wall sizes, 2x4, 2x6, I'm not from Canada, I'm from Europe. 2x4, I thought it was 2x4 inch, but it's 3.5 inch. So all the walls were modeled as 4 inch, but they were not 4 inch, they were thicker, they were thinner. So all the coordination that we did with that 6 inch part going in a 6 inch 2x6, it doesn't really fit. So everything that we came across, we redesigned it, picked it up and changed it so that we can actually build and use the sizes that we use in our early stage 3D modeling to coordinate it on site. We also talked to, like Jai was saying, we talked to a lot of different people within the company, and therefore putting codes and other structures in place for that model was very important to extract that data. So we talked to estimators, we talked to framers, we talked to guys that did the actual installation of the ducts. And all of those people came back with information that we translated back to an early design model to be able to extract that information for them. So like we said, model data like master format, uniformat, we put in obviously the correct materials, family and type names, and the correct entities. So if it's a wall, it's model as a wall. And a lot, like it sounds very logic, but if I look, especially if you make a bridge to the high-rise projects, if you open those up and you look at the amount of entities that are used or misused for what they are supposed to be, that's crazy. So we try to stick to those entities as much as possible. Then the other complexity Jed already told you, design options. And those design options, so what we did for those houses, so we have those 20 different house types. Those 20 different house types have 4 different styles, and then 10 different design options per style. All those different options are modeled in one Revit model, on top with design options. It makes it super complex to build that model, but what we can do is we can keep changing those things, and everything stays within that one single source of truth. And then in the end, we overlay that template, and that template file will extract the correct information coming from there. Before we overlay that template file, we do the coordination. And like Jed was saying, and this is more or less a similar picture as what we saw, is we have those 4 different or 5 different discipline models, and those different discipline models grow every day. So we get window manufacturers, stair manufacturers, kitchen manufacturers in there to start coordinating with all those different basic models. We coordinate it, we put them in a cloud platform, and after that we extract that necessary information. But important is, and we get more and more positive feedback from the guys at Mattamy, that they're saying this is amazing. Now I can see how my building actually looks. I can see where there's a potential bulkhead. I can see where the changes have to happen because HVAC and framing is working together. So they have direct access to whatever is going on here, and they can communicate with each other. Well, that we could do that with email as well, but doing that through the cloud platform makes it a lot easier and a lot easier to track for everyone what happened in the past. So again, to point out how we built those models, this is a small cutout for a 30-foot lot. So we have exterior wall finishes. We have an HVAC discipline model. We also have the wood frame model, walls. They're modeled by us still. And then we have the wood frame floors as well. What we can do is we can switch off, because we coded all those wood frame objects, we can switch them off. We can take them out there, and then you can easily see how the HVAC model is integrated in that design model, and we switch on the framing model. It sounds easy, it is kind of easy once you figured it out, but this gives us a very visual way of extracting information. And one of the things that we saw as an example was that the return air for a house is not being done by ducts, but it's in most of the times joist liner or something else, so there's no real physical object. One of the choices that we made is we model the physical object so that we can still clash and see where that joist liner or stud spacing is needed to be able to run that return air through the house. And around those models, we have them all in the cloud, like I said. So you see here that we have 5 different house models on top of each other. What we do is, our clients, Mattamy Homes, the project coordinators, everyone that has access to that platform is able to make sections, look at all the different models, switch them on and off. So for this example, I switched off the architectural model. It's still ghosted on the back end, so you have a good idea on what's going on in that house. We make some issues, we came across a problem. We assign that to the person that is responsible for it to solve it. And we also track that solution. And what happens often is that I think all the models that we saw from the HVAC design came in 2D. We modeled them into 3D and we took them back into the framing model. Everything that we touched wasn't fitting. Everything was wrong, basically. Sometimes it's small, sometimes it's bigger, but what we're aiming for here is that we coordinate in the beginning, and in the end what we want to do is we want to get it to a point where what we have here is also built on site, because that last problem is also something that we recognize. Because that framer that goes on site or the guy that installs the HVAC ducts might still make a different decision here than what we came up with. And then this is more like a PDF, so it's a kind of a traditional type of thing, but still what we do is all the clashes that we find in the model, we track it, we group them together, and we save that for records later, so that we can also always go back to what decision did we make at that point in time, so that we can always go and track back on why we did things. And now the other important thing, so this is the structure of the model, so all that data is sorted and is coordinated. Now what do we get out of it? This is a small list of what we can get out of it, and all the orange elements are what we're going to talk about. This slide is also in the presentation, is available online, so go ahead and have a look at that later. I don't know if you remember, but what we did, or what we explained in the beginning, is we have that 3D model, and that 3D model is overlaid by a template. So we have the 3D model with the structured data, we overlay it with a template, and we can extract all that information out of that 3D model. Our idea is that whenever you have that 3D model, all those design options and all the styles are in that same 3D model, and the template coordinates the information that we want to look at. So in this case, as an example, this is a traditional architectural drawing we extracted from the floor plan, but we're also able to extract customer information, the sales drawings. And all the text and things that you see here, all the information that you see here in 2D, is not actually in our template, but that's something we saw as data that is super important to put in our actual 3D model. Because what we saw is that because people are not consistent in naming their objects and naming the rooms that we're in, it's for us super important to have those elements standardized. So that is part of why we have it in our design model instead of having that as a 2D element later in your annotation process. Also, things that are very time sensitive, because it's taking a lot of time to put all those elements in. It's easier to embed it in a family than have it in a 2D text element. And this drawing, and that's something that was a big step, a big improvement, is this drawing traditionally came from AutoCAD, then was cleared up, like all the layers were taken off, and there were like hatches and everything else was cleaned to make it look like this, but it didn't come from that same source. So we saw, when we looked at sales drawings and we looked at drawings coming from the architect for permits or construction, they were different. So the client bought something different from what we're talking about on site or with the city. And because all this information comes from our Revit model, and it's the same information that we send out to the city, we're able to create that output, and it's exactly reflecting what we're also submitting to the city. Similar to all those things, you know the viewpoints or the how do you call those elements in AutoCAD? The viewports in AutoCAD. This is all related directly to the 3D model. So whatever we change in this area, it will also change in that little cutout there. And that's stuff that we saw wasn't happening in the traditional process. So again, you have that 3D model, you have the template, you have the BIM output. And if you look at what we get from like specific output, so that's more the IKEA way of thinking or looking at information. So we drill down that information and extract specific information for value engineering. Value engineering, look at it as we're looking at our project and we want to make decisions based on numbers instead of based on a gut feeling. This house is too expensive, we need more siding instead of brick, so what happens if we take off the brick a little bit and put more siding on it? They didn't have that information in the past. This model with the overlay of the value engineering template, as we call it, gives you this information instantly. Same for this house, so you can see the difference between styles. And also filtered not only for the brick or the cladding, but also filtered for all the different styles of houses. So this gives more an insight on, is there a difference between the foundation for style A compared to style C? it's the same house type, so the floor plan is the same, but are we making cost based on the style that we designed because of all those like small changes that the architect made? This inside, they didn't have that before. Same for the roof, or the floor finishes, or ceilings. And then HVAC, obviously they didn't have that insight in the past of like what is in that model. We only had the 2D plans, and then everything was done in AutoCAD, manually calculated with lengths and everything. All elbows are taking account, but then we make a change. Is that elbow still taking into account? So it's changing because we have that insight in the HVAC model. And then sales and marketing, like I was saying, we're able to use that same 3D model without any cleaning up of hatches or anything. It's still the same 3D model that we extracted information from. And it's extracting or it's creating those floor plans. And like I was saying, those families, for example, here the kitchen family, but also the exterior door, that little piece of text, the sliding door, that's not in the actual annotation, but we put it in the family for the techies. Similar here, so everything's coming from that same model. Also floor plan or elevations, and in that elevation, that's what Revit does, is if you look at that elevation, it's obviously reflecting the design options if you pick them as well. And then as an extra, what happened is we had the sales process where it went to the drawings that were actually contract documents, but this is the documents that are in the sales brochures. It's a different source of information. They follow the same process for that, but the scale is a little bit different, the layout is a little bit different, so they had a similar or a separate process for that. We all streamlined that, and now we're able to link that same Revit model into brochures or into the website to get that information working for us. And as a final thing, we use that same 3D model as a source or as an underlay for creating the renders. So we have set up a pipeline where we standardize that process so we don't have to go over all the changes and have to mark, okay, we changed the way that window looked, you need to change that back in the render. The Revit model is as an underlay and works the same as under all those other elements. Those are the familiar kind of outputs. Maybe the value engineering is kind of new, but then what we also did is we talked to our estimation team. And the way we approach this implementation, we're not going from 1 to 100 in one step. So this is like a step in between for us, where we found that they were coloring drawings on their couch when they had some spare time. So they were watching Netflix and coloring drawings to make sure that the quantities are, that they can use that time to make up for the time that they lost during their long meetings during the day. This template colors floor finishes, gives the area of those floor finishes, and this takes care of, let's say, 40-50% of their estimation, their quantity takeoff process. For us, it's fairly easy. For them, it was taking a lot of time. And then whenever a change happens, they have to go back to Bluebeam or OnScreen or to another program that they're using and redo it, because it's not giving you those changes. Whereas if we make a change in the Revit model, it reflects here. So same for this. And then another thing, and this one, I think the previous one was not the coloring, it was this one. So they had actual markers. I talked to the manager for procurement. She was saying, like, back in the days, I was on my couch coloring. Well, this, we all know Revit can do this. So we talked to them, we extracted the information from them that we needed, that they needed, and we got this to work for them. We use this information. You don't see any quantities on this screen, because the quantities, we took that off because they use this information to coordinate with their trades. They're not at the point yet that they say, okay, we want to take over that responsibility for getting the right quantities out there. So that's still something that is with the trades right now, but they have that better information out there. And you can imagine that if you want to color this, if you want to get your siding to show up in purple, you need to tell that siding that it's siding. You need to give it a code or whatever. You need to be very accurate in the naming of the objects, otherwise it doesn't work. So you're looking at a house, but if you're more in the high-rise world, and you're also coordinating with trades, you can see the similarities to whatever is in the high-rise world compared to what we do here. Same for stairs. They had a lot of coordination issues with that people didn't understand what the shape of the stair was, so we filter out the stair, put it on a sheet, put some dimensions on it. Sounds easy. It isn't that hard, but getting that information out of people and putting it on that sheet, that's where I think the implementation power lies. And then quantity takeoff itself. So here, this is one style. So this is a 30-footer. And we extract all this information from it and we project it next to each other. So the 4 styles, and especially here, as you can see, the exterior wall finish is one of the biggest cost elements of the model. So we put them next to each other and we show visually where's the differences, which one is the highest, which one is the lowest, and is that aligned with what you were thinking. And a lot of times when we were talking to the estimation guys or the architectural department, this was kind of a surprise that there were differences between one another where they were convinced that it was the same. So it is a lot of extra insight that they got from those elements. And this is not a Revit template, but this is a Navisworks template that we developed for. And then finally, and this is that, I wouldn't say 1 to 100%, but this is the next step that we're taking, and we're currently doing this with them, is we're doing actual estimation on the models. So our step is to get that information that they now currently do in, I think it's Bluebeam, but they also use on-screen, and we convert that to a process where they can do quantity takeoff on the 3D model. Obviously, and that's always the problem with estimation, I think about 60 to 70% you can get from the model. The other 30% is still elements that are not modeled. And there's also always the balance between do I model it, yes or no. And this program that we're using is also giving us a 2D option. So we can combine the 2D and the 3D elements together into one source, and we can extract and use that information in our estimates. That's also that step where people are, especially the estimation department, they're very used to what they do. They don't want to change a lot. So when we showed them the 2D solution, they were like, oh, yes. And then we gave them the 3D extra option for that. Well, construction documents, we already talked about it. And this is where the elements, like I told you, the texting that you see here around those basement windows, those texts are standard in our model. So everything that we build in a model automatically gives the right information, so we won't forget any information on those drawings. Similar to this. And then if you look at this construction, like obviously we also have that information where we talk about the PPOs, or the options. And we're talking here about the construction documents, and up there is permanent documents. The reason why we made that difference is when you go to permanent, you use those elements where you show the option and you show the actual design. The construction documents, that's more for us as the site specifics. So in the end, when the client buys the house, they pick all the options, we'll merge them together and print that one construction document for also the guys on site, so they don't use 4 different drawings. They have to put them on top of each other or use a list. Well, like, okay, did this client choose the chef's kitchen? Did they choose another option for the bathroom? Oh, so then I don't need to follow this drawing, but I need to go to that one. So we believe that whenever IKEA can do that on a simple closet, why can't we on a house, right? It's kind of more complex. And then if you look at the HVAC, traditionally, especially in low-rise, it's a single line drawing. So you have one line and that reflects the duct. It gives the information about how big the duct is. It doesn't tell you how it works together with the framing. But in this case, what we do, and this drawing actually evolved, so we flipped the pictures. The big picture is now the one with the framing and the double lines in it, so the guy that does HVAC actually sees what the framing will be looking like when they arrive to site. Jed already talked about this, so it's filtering down about everything that is made of concrete in the project. This is the guys go to site. This is what they have to deliver when they leave. Similar for this. This information is never on the drawings for an actual bricklayer. It's always the size of the window, or it's another size. So I actually went to site once and there were guys walking around with a calculator to make sense of all the dimensions on that drawing. This drawing is made for that. Same here. The lessons learned. So what did we pick up from this process, and what do we think is very important if you start working with BIM, or if you're already there but you're like kind of stuck in what to do next? One of the biggest things we saw is, or important things, is start small but with the bigger picture in mind. So I think having a vision, know where you want to go is very important, but don't go into a small room with all your small techie guys or your smart techie guys. Start thinking about a very big plan and then start working. Start with the small little steps that you can take, and obviously go for the low-hanging fruit first. So what we saw with those sales drawings, with those marketing drawings, we saw that there was a lot of double work and a lot of inconsistencies. So we focused on that first. And that was a big success for us. So therefore, all the people that we were talking to, they were instantly engaged and wanted to work with BIM. This happens a lot. I like the idea of Henry Ford, where he's saying, like, if I would have asked the people, they would have asked for faster horses. When you do BIM, it's not about creating better drawings. It's about creating better information. And that it is a drawing as information that's possible, but it is always about creating that next step instead of that making faster horses or better drawings. And that's similar to what we showed you earlier in those pictures with those extracting drawings from the model. We showed you this today, hopefully. The integration between different disciplines. So we're talking to the guys from procurement, we're talking to the site guys, we're talking to guys not even within Mattamy, but they're also trades or other consultants. To make that oil or make that chain of people that work with BIM as big as possible. Don't create one island where you only sit and do your smart 3D modeling, but get as much people involved. Especially, like we were talking about low rise, but I think if you talk about high rise, it's similar there. Maybe this should be first, but to be able to do that, you need to talk to people and know what they want. And we saw it a lot in our meetings, that people walk into a room, they've been working together for a year or two, and then they had to shake their hand because they didn't meet before. They were talking on the phone, they were sending emails or whatever, but they were never talking or meeting, and they were never like actually connecting on what do you need to do your job properly. And that's what I think we add to that process, where we keep asking why, and then when we get to the point where we think, okay, now we are at the MVP, the minimal viable product, we're going to build that. Then if you look at the differences that is coming from working with BIM compared to the traditional process, the process is most of the time sequential. So what we showed you, you create a drawing and then you start cleaning it up and you extract that or use that information. All the disciplines are separate, so they're not aligned, and that one person, look at this, is the builder, he's coordinating everything. So he's that spider in the center of the web, and he's creating all the solutions, but also all the problems. And all those people are not talking to each other, but only through that builder or through the architect. And then look at this as a fence. So people, like I told you, they throw it over the fence and say, well, like, this is my information, this is the best that I could come up with. Use it. I don't care if you understand or can work with it. And then the reactive part is a lot of people just send out an email and start waiting. Right? Whereas if you change into a BIM world, I think it's more a parallel process, so people start working together closely. It's an integrated process, so everyone's connected through that cloud and they can all talk to each other. Obviously, you can streamline it a little bit. You don't want to have everyone connected to everyone at the same time, but still, the more transparency, the better, like you see there. And then obviously proactive. So we need, I think, a different type of processes, but we also need a different type of people, or a change in the mentality of people, that it's not scary to collaborate and show what you need and start talking to each other. I think this is pretty good.
So to wrap all this up and summarize some of the things that we've done, and we also want to say that although everything is great, starting with BIM and doing all these things, but obviously at the end of the day it comes down to the dollar value and the business case for BIM. I think that's important to mention and go through some of the things that we went through, because it's not just about the pretty drawings and the models. Somebody has to be paying for this. There should be some return on the investment in implementing BIM and so on. So one thing we did on a very high level, just did a quick analysis of how long it was taken for the traditional process versus the BIM process, and the savings in time for a single house. So if you time this by, for example, 20 different house models, the savings in time could be this. That doesn't really tell the full story. It doesn't have all the different disciplines in there. And then comparing BIM to traditional, I think it's a little unfair because it's really apples to oranges. And the reason why is simple. It's basically this. So going back to the idea that we have is the BIM model, the templates, and the BIM output, let's dissect that a little bit more just to give you a full understanding of what's actually going on the business point or behind the scenes. So in the traditional process, when you look at CAD, it's not only just the CAD versus Revit scenario. It's more, or CAD, or basically stands for computer-aided drawings. It's basically a digitized hand drawings. That's really what it is. And it comes with layers, lines, 2D blocks, print styles, and text. Information that you can't really use or extract other than to produce a drawing. In the CAD process, you have to create your files, then you have to create your CAD templates, and then you create the 2D output. So that's kind of how it goes. In terms of the breakdown of the time spent, well, each one of these processes, first of all, are 100% manual, and you spend 40% of your time doing the first part, 30, roughly depends on the project. The other problem is that when you move from one stage to another, you end up copying the document. So now you've created a new source, and you keep adding the information to it. And every time you need to change, you have to go back to the first one and redo the process. Now, if you look at BIM, first of all, you have 3D models, you have data, you are working with actual building components, you're using proper materials, you have access to intelligence, and you have all the systems built in, like the HVAC wood framing and so on. So in the BIM process, however, the breakdown looks something more like that. You invest more time in the beginning in your BIM models, which is basically 80% of the work, but it's 80% of intelligence work, not just sort of 2D information. And then the other two stages, the BIM templates and the 3D outputs, are only 10% of the work, and they're 90% automated anyway, so the user input is not that high. So for us, we wanted to let people or humans spend their time in the beginning, because we're intelligent species. We didn't want people to copy paste things and add dimensions into CAD templates, where something like coding or scripts or programming can take care of. And we use a lot of that in our drawings. So most of our drawings are set up by Dynamo scripts. We don't really copy paste a lot of things. All the sheets are automated, naming and things like that. So that's why 90% of the process is automated, which means if I change my BIM models due to any reason, design changes or different sales options, I can always re-output these templates and 3D outputs or 2D outputs, the ones that we ran through earlier, fairly quickly. It only takes 10% of my time to do that versus the original process. Because I am not copying my source, I'm working on the same source. So finally, if we look at the two processes together, let's say they take 100% of the time. However, the reality is that the BIM process, with all its benefits, is actually up to 30% faster than the traditional process. So you're not only faster, but you're also gaining all the benefits. But that's also not the full story, because if we add the benefits to that, which you basically have, you can accommodate for design changes, you have coordinated designs, you have all this data and intelligence in your models, and you're able to create lot-specific drawings, then the savings are up to, I would say, 50% from what we've learned or sort of documented over the past year and a half to 2 years working in this area. So that sounds great, but the truth is, the true cost of BIM implementation, you need to keep that in mind. First of all, you need to deploy a BIM team, and this could be, from higher level BIM managers, specialized people to lower level BIM modelers and people who are able to do the work. Then you need to go through the upgrade of your software and hardware cycle, which can be quite expensive. The biggest thing that a lot of people don't count is the surge of projects. Meaning, I'm working on a BIM project today, and I've deployed my team in software and hardware. Tomorrow, I don't have another BIM project. What do I do with all this infrastructure that I just put in place? And that's a very, very big problem. The biggest problem also is bringing the higher level knowledge and expertise to be able to manage all those resources that you put in and cope with the surge of the projects. Now, obviously, the solution would be to bring an outside counsel that has all those resources to your BIM team. But we also think that's not really the good solution, and that's why a lot of the BIM implementations fail. The real implementation should look more like this: an integrated implementation, where everybody works together in the same environment, tapping into the same resources or sharing the resources. The team that you have in-house will be updated and upgraded to the new BIM processes, and then you're able to use outside sort of expertise to be able to help you out with that integration. That's kind of how we see it. So basically, the reason we started BIMstudio really is to accelerate the adoption of BIM in the AEC industry, because we believe that if everybody jumps on BIM, it will all be better. So, for example, right now with Mattamy, the biggest problem is finding people that are willing to work in the BIM process, which doesn't give them a very good competitive advantage because of prices. But if there's like 10 different consultants willing to do HVAC and BIM, then now you can tender your projects to more people versus just one firm. There's more builders or more site supers are willing to use BIM on site, then now you can, have your competitive advantage back. So that's kind of the bridge that we need to cross from having BIM implemented on a very low scale to large scale to be able to tap into the economy of scale and just be better at BIM.